right, Sima? So already we discussed methods of integration. In that methods of integration, I told 3 type of methods there. One is integration by this one, another part what here, integration by partial fractions there. Integration by partial fractions. Next second, third one what integration by parts. Okay na? So integration by substitution already we completed that first part, integration by substitution, and second one integration by partial fraction, third one what integration by parts. So already we completed integration by substitution method completely, that method over. Now integration by partial fraction. So now in this class first we discuss what is the partial fractions. What is the partial fractions? So now if we define partial fraction means already if we learn some basic concepts about polynomials in lower section. So once again I revise that basic concept of polynomials for this partial fractions. What is polynomial? What is polynomial? So an expression of the form f of x is equal to, an expression of the form f of x is equal to a naught plus a1 into x plus a2 into x square plus and so on an into x power n. An expression of the form f of x is equal to a naught a1x a2 plus x square a2x square plus and so on an into x power n, where n is non-negative integer, here what ma, n is a non-negative integer, and these values a naught, a1 and so on an are real numbers, and here one condition there ma, and a naught is not equal to 0, and a naught is not equal to 0, and here an is not equal to 0, then an is not equal to 0, then is called a polynomial in x variable of degree n. An is not equal to 0 is called a polynomial, in x variable, and the degree is n, okay na? So if you want to take example quadratic there, x square plus 3x plus 4, x square plus 3x plus 4, this is the one polynomial expression. Next if you want to try down x cube plus 3x square plus 4x plus 7 or x minus 7, this is also a polynomial. So this is the quadratic, this is the cubic, this is the linear polynomial, okay na? Now next we define degree of a polynomial, degree of a polynomial. Degree of a polynomial. So how do we define degree of a polynomial means ma, if the degree of a polynomial, of f of x, the degree of a polynomial of f of x in x is the highest power in x, okay na? So what is the degree of a polynomial? If the degree of a polynomial f of x in x is the highest power in x, any polynomial given, so the degree if you want, so then, and we denoted this value degree of f of x, if you denoted this one degree of f of x. Here see ma, this is one polynomial no. Now what is the degree of this polynomial? Degree of this polynomial x square plus 3x plus 4x is equal to what we have done in this polynomial, x variable highest power what 2. So that's why 2 is the degree of this polynomial, and here what is the degree of this polynomial? X cube plus 3x square plus 4x plus 7. Now what is the degree of this polynomial? Highest power is 3. Then again here degree of this polynomial is equal to 1 value. Okay, na? Clear that one? So degree of polynomial, how to define means in the given polynomial, the which variable having the highest power, that power is called the degree of the polynomial. Degree of the polynomial. Next one, rational fraction. Rational fraction. Rational fraction. So already we discussed polynomial and the degree of polynomial. Next, rational fraction. Here if f of x and g of x or any two polynomials and g of x is not equal to 0 and g of x is not equal to 0, then f of x by g of x is called rational fraction. Rational fraction or rational function. Okay, na? So rational fraction means what? If f of x and g of x are any two polynomials and g of x is not equal to 0, then f of x by g of x is called the rational fraction or rational function. Now if we want to give any examples, means rational fraction, so then what we done here? 2x by x square minus 1. Okay, now this is also a polynomial, two polynomials. Then here value what we done here? Here value if you want to write down, suppose x cube plus 4 by x minus 1. So these are all rational fractions. Now if we define rational fractions in two types of rational fractions, so many types there, but here we discuss the depends on the degree, the given polynomial's degree. If we classified two types of rational fractions there. So first one, proper and improper fractions. Proper and improper fractions. So very important one, this one, proper and improper fraction. By if you want to solving the partial fraction, if you verify the given fraction, which type of fraction, the given rational fraction, which type of rational fraction, proper or improper. So proper means condition what? So proper fraction means if we take any one fraction, so that fraction means suppose f of x by g of x, any one rational fraction. Now this rational fraction is said to be proper fraction. Then condition what means here? Degree of f of x is less than degree of g of x. Okay, na? So proper means what? Degree of f of x is less than degree of g of x. Otherwise improper, then f of x by g of x is said to be improper. Degree of f of x is greater than or equal to degree of g of x. Is greater than or equal to degree of g of x. Proper fraction means the given rational fraction is said to be proper. Degree of f of x is less than degree of g of x, means numerator degree comparing with denominator degree is lesser, then that fraction is said to be proper fraction. Improper means the degree of f of x is greater than or equal to degree of g of x is said to be improper fraction. Okay na? So if you want to take examples for some examples for proper or improper, here see ma, first give us some examples here. X plus 1 by x square plus 3. Now this is proper or improper? Here degree is 1. This degree how much ma? Degree of numerator, degree is 1. Now this degree how much ma? Degree is 2. Comparing this one is less than 2. So that's why this is the proper. So this one what ma? Proper. Next, improper means x cube plus 4x plus 7 by x square plus 7, or x cube plus 4x plus 7 by x cube minus 4x plus 7. Now what we verify here, comparing with this degree, first numerator degree, degree is 3. Here degree how much ma? Here degree is 2. 3 is greater than 2. 3 is greater than 2. Now here degree of numerator is 1. Sorry, 3. So degree of denominator is also 3. Now what we done here, relation 3 is equal to 3. So degree of f of x is greater than or equal to degree of g of x. So that's why these two are improper fraction. This is the proper fraction. Okay na? Clear? Right, Sima? So already we discussed proper, improper fractions. So proper means what ma? Degree of f of x means numerator value. Degree of numerator is less than degree of denominator. Then that fraction is said to be proper fraction. Or degree of numerator is greater than or equal to degree of denominator. Then the fraction is said to be improper fraction. But here one point we remember, whenever any one fraction, suppose if f of x by g of x is an improper fraction, Now f of x by g of x is an improper fraction, then that fraction must and should be converted into proper fraction. If f of x by g of x is an improper fraction, now we want to convert. Now we want to convert proper fraction by using long division method. Okay na? So f of x by g of x is an improper fraction. Now we want to convert this proper fraction by using the long division method. Where we are applying this condition means in partial fraction integration. If you are applying the integration on partial fraction, whenever improper fraction there must and should be converted into proper by using the long division method. Means what? So here g of x divisible with f of x, then must and should be get some quotient, that value q of x or q of x, then here reminder what ma? R of x value. Now we are applying the division algorithm. What we are done here, f of x is equal to g of x into q of x plus r of x, totally divisible with g of x. Then what we are done here, f of x by g of x is equal to g of x into q of x by g of x plus r of x by g of x value. Then if you run this value, f of x by g of x is equal to g of x cancellation q of x, here q of x plus r of x by g of x value. So this is the process in partial integration, partial fraction. If you want to convert it improper fraction in proper fraction, then we applying this long division method, we converted this form. Okay na? Sima, another one, irreducible polynomial. This is also important in partial fractions, irreducible polynomial. Here what given irreducible polynomial? A polynomial f of x is said to be irreducible. Any polynomial is said to be irreducible if it cannot be expressed as the product of two polynomials, g of x and h of x. and these degrees non-zero degree such that each degree of polynomial, this one g of x and h of x less than the degree of f of x, compulsory less than the degree of f of x. For example, if you take irreducible polynomial means, example ma, if you take here x square plus 1 there, then how to write down this is product of two polynomials possible? So not possible. Such type of polynomials are said to be irreducible polynomial. Otherwise, if you want to write down x square plus 7, this is also splitting not possible. Factors splitting not possible. So that's why these two are the examples of irreducible polynomial. Irreducible polynomial. And a reducible polynomial means which are not irreducible. Those are called the reducible polynomial. Reducible polynomial. Sima, here example, if you want to take x square minus 1. So irreducible means what? Given polynomial cannot be expressed as the product of two forms, two polynomial. But this one, product of two polynomial is possible. Okay na? Now this is the reducible polynomial. Again condition what given? Two polynomials if we taken, every polynomial degree must and should be less than the given f of x value. Otherwise, if you want to write down x power 4 minus 1, then how to write down this value? X square minus 1 into x square plus 1 value. Now this is also similar, each polynomial degree less than with the given polynomial. Here 4 there, here 2 value there. So now these type of polynomials are said to be reducible polynomial. Reducible polynomial, and this is the irreducible polynomial. Partial fraction. Partial fraction. Now main definition ma partial fraction. Already we learn basics of that partial fractions. Here how to define partial fraction means ma, a rational fraction f of x by g of x comma g of x is not equal to 0 can be expressed as the sum of two or more, if rational fraction f of x by g of x can be expressed as the sum of two or more proper fractions, two or more proper fractions, then each proper fraction is said to be partial fraction of the given fraction. Okay na? A rational fraction f of x by g of x can be expressed as the sum of two or more proper fractions. Then each proper fraction is said to be partial fraction of the given fraction. For example, if we take 2x by x minus 1 into x plus 1, then how do we represent this value is equal to means, suppose if you represent this value means 1 by x minus 1 x plus 1, 1 by x plus 1 plus 1 by x minus 1. Sima LCM x minus 1 x plus 1 x plus 2x 1 cancellation. Then each, suppose here 1 by x plus 1 is a partial fraction of 2x by x minus 1 into x plus 1, and again 1 by x minus 1 is a partial fraction of 2x by x minus 1 into x plus 1 value. Okay na? So that is each fraction is said to be partial fraction of the given fraction. So partial fraction means what? The given rational fraction can be expressed as the sum of two or more proper fractions. Then each fraction is said to be partial fraction of the given fraction. Okay, ma? Now we discussed that partial fractions. So partial fraction means what? The given rational fraction can be expressed as the sum of two or more proper fractions. Then each proper fraction is said to be partial fraction of the given fraction. Here different type of models, types there. In that types he given some types here. First, the given proper fraction means the given fraction, the denominator value having the linear factor product. X minus a, x minus b is the linear factors. So in the given fraction, the denominator having the linear factor product, then how do we represent some of the partial fractions? Means first factor, anyone if you select linear factor, anyone we select a by x minus a plus b by x minus b, only product there, linear factors there, means then this is the form of that partial fractions form. A by x minus a, form of the partial fraction, a by x minus a plus b by x minus b. Okay na? Otherwise the denominator having the linear factor only but repeated, means power x minus a whole square, x minus a whole cube, like that given. So how many times are repeated? That number of time if you reduce the power, suppose here x minus a whole square given, first value x minus a, next value x minus 2, otherwise here x power 4 given, x minus 2 whole square, x minus a whole cube, x minus a whole power 4, number power how much there? That number of times if you reduce the power. So that's why a by x minus a, b by x minus a whole square value. Okay na? That is the first case, only non-repeated linear factors. Second case, repeated linear factor. Third case, here also non-repeated, means non-repeated linear factor product given. 3 times there. First one 2 times there means AB. 3 times there means A by B by C by value. Next, fourth one what here? Denominator value. One repeated, another one non-repeated linear factor. One repeated, non-repeated. Same process here also. First we read on the non-repeated linear factor a by x minus a, or repeated also read on, no problem. Here a by x minus a, b by x minus a whole square, repeated over. Next c by x minus b, non-repeated. Okay na? Here particular condition not them, anywhere if you read on this value. Okay na? Non-repeated or repeated, x minus a whole square, x minus b, a by b by c by. So that is the fourth one. Means what? First one non-repeated linear factors, next repeated linear factors, next third case what? Repeated and non-repeated, 3 cases over. Next this one if you taken means here see denominator x minus a, non-repeated. Next ax square plus bx plus c, this is the quadratic expression, but he mentioned here this quadratic expression factors is not possible. Factors is not possible means which type of polynomial? That is irreducible polynomial, x square plus 1 or x square plus 7, such type of irreducible polynomial. Whenever irreducible polynomial given, then how to write on that? Partial fractions. First non-repeated a by x minus a plus, this is the non-repeated. So bx plus c by non-repeated polynomial, ax irreducible polynomial, ax square plus bx plus c value. This is the important case. Here important case means what? This is the quadratic expression is the irreducible polynomial. Irreducible means already explained that given polynomial factors cannot be expressed in the product of the polynomial. Such type of polynomials are said to be irreducible. So that's why here factors are not possible means this is the irreducible. Whenever irreducible, if you want to write down means partial fraction bx plus c, 2 terms bx plus c by that irreducible polynomial. So this is the structure. What is the structure? What here? Form the rational fractions. He given the rational fractions, we converted into partial fraction, then we using this table and we simplifying the integration of the given rational fractions. That partial fraction concept over. Next that concept related one exercise given exercise 7.5, integrate the rational fractions in the following. Integrate the rational fractions in the following. So first question integral x by x plus 1 into x plus 2 dx. Integral x by x plus 1 into x plus 2 dx. Just we recall that table, any rational fraction given, if you want to convert it into partial fractions. Here condition what ma? First point. So the denominator having the non-repeated linear factor. Non-repeated linear factor. So then how to write on this non-repeated linear factor means ma? First we take that given rational fraction x by x plus 1 into x plus 2 is equal to first a by x plus 1 plus b by x plus 2. If you represent the given rational fraction in terms of partial fraction. Now, if you take LCM, LCM means what? A into x plus 2 plus b into x plus 1 by x plus 1 into x plus 2. Here ma denominator same. Here denominator same. Just be comparing the numerator value. X is equal to a into x plus 2 plus b into x plus 1 value. Now, if you comparing the coefficients of x and a constant term on both sides, comparing coefficients of x and constant terms on both sides. Constant terms on both sides. Okay na? Comparing the coefficients of x and constant term on both sides. See ma, here x coefficient a, here x coefficient b. So a plus b. Otherwise a plus b is equal to 1 value. A plus b is equal to 1, or this one ma constant 2a plus b is equal to 0. Here constant not there ma, 2a plus b is equal to 0. Then b is equal to what for here? B is equal to minus 2a. B is equal to minus 2a. B is equal to minus 2a. Now the 2a value here we substitute ma. Then what for here? A minus 2a is equal to 1, a is equal to, here a minus 2a, minus a. Minus a means a is equal to minus 1 value. A is equal to minus 1. Then b is equal to how much, Sima? A is equal to minus 1, b is equal to minus 1 into 2 value. Okay na? Ma, this is the general process. Simple method means if you substitute the value, if you eliminate any one term, suppose here Sima put x is equal to minus 1, put x is equal to minus 1, this value become as a 0. So minus 1 plus 2, a is equal to minus 1, a is equal to minus 1. Put x is equal to minus 2 in that equation. Minus 2 plus 2, 0, a 0. So minus 2 plus 1, minus 1. Here how much written? Minus 2. So minus b, minus 2 is b is equal to 2 value. That is easy method. Next problem I explained that method only. So here if you find out the a value and the b value, this is equation 1. From equation 1. From equation 1. Then what we done here? X by x plus 1 into x plus 2 is equal to, a is equal to minus 1 by x plus 1 plus 2 x plus 2, 2 by x plus 2. Now integrate on both sides. So integral x by x plus 1 into x plus 2 dx is equal to minus 1 integral 1 by x plus 1 dx plus 2 into integral 1 by x plus 2 dx value. Okay na? 2x to dx value. Now what we are done here? That is equal to 1 by x formula minus 1 by log of x plus 1 plus 2 into log of x plus 2 plus c. Which one this one? Here f of x, f dash of x by f of x, derivative how much? 1 value there. Here derivative 1 value there. So that's why if you write on this value. Otherwise if you want to write on this value, over answer. Otherwise if you want means whole square. This one, x plus whole square by log of by n value. Okay na? So this is the answer for this partial fraction. So this is the solution over. Otherwise if you want to write on simplification means what we write on this value whole square log m minus n formula log of this value x plus 2 whole square by this value how much? X plus 1, okay na, plus c value. Correct. second question, integral 1 by x square minus 9 dx, integral 1 by x square minus 9 into dx. Okay na? First we take that rational fraction 1 by x square minus 9 is equal to, first we factorize this one, means x minus 3 into x plus 3, correct? A square minus b square, a plus b into a minus b, that is equal to a by x minus 3 plus b by x plus 3 value. So this is equation 1. Now if you simplifying this value, so denominator means LCM if you taken here, LCM if you taken means a into x plus 3 plus b into x minus 3 by x minus 3 into x plus 3. Here denominators are same, so 1 is equal to numerator value a into x plus 3 plus b into x minus 3 value. Okay na? Now if we take this value, equation 2, put x is equal to 3 in equation 2. So x is equal to 3 in equation 2. 3 minus 3, 0. This total value is equal to 0. So 1 is equal to a into 3 plus 3. Then a is equal to 1 by 6. A is equal to 1 by 6. And similarly, put x is equal to minus 3 in equation 2. Minus 3 in equation 2. So 1 is equal to a into minus 3 plus 3 plus b into minus 3 minus 3. A value 0. Then 1 is equal to minus 6 into b. B is equal to minus 1 by 6 value. So a value and b value. Now if you find out the substitution, a value and b value from equation 1. From equation 1. So what we done here? 1 by x square minus 9 is equal to, here finally if you done here, a by means 1 by 6 into x minus 3 minus 1 by 6 into x plus 3 value. Now if we take integral 1 by x square minus 9 dx is equal to 1 by 6 integral 1 by x minus 3 dx minus 1 by 6 integral x plus 3 dx value. Okay na? So overall if you take 1 by x 6 common, then this value what ma? Log of x minus 3. Now this value ma? Log of x minus 3 minus log of x plus 3 plus c value. So finally what we done here? 1 by 6 into log of x minus 3 by x plus 3 plus c value. So this is the partial fraction method. Right, Sima? Third question, same model, but here linear factor non-repeated product form there. So here solution, what we done? Rational fraction 3x minus 1 by x minus 1 into x minus 2 into x minus 3, that is equal to a by x minus 1 plus b by x minus 2 plus c by x minus 3 value. Okay na? Now if we take LCM how much ma here? 3 factors, x minus 1 and x minus 2, next ma x minus 3. Okay na? LCM method ma x minus 1 cancellation, remaining 2 terms there, a into x minus 2 x minus 3 plus b into x minus 2 cancellation, next x minus 1 into x minus 3 plus c into x minus 3 cancellation, x minus 1 into x minus 2 value. Okay na? Now what we done here? 3x minus 1 is equal to a into denominator same, x minus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. So this is equation 1 this one, and this is equation 2. Now if you want to find out here 3 unknown variables, a value, b value and c value. How to find? Eliminator method. See, here first we substituted x is equal to 1, then b value 0, c value 0. Then if we get the value, a value. X is equal to 2, right? 2 means a value 0, c value 0. Then if we get b value, x is equal to 3, right? A value and b value. Then if we get 3. So that's why what we done here, put x is equal to 1, 2 and 3 respectively. 1, 2 and 3 in equation 2. So 1 by 1 we substituted 1, 2 and 3 in equation 2. So put x is equal to 1. Then 3 into 1 minus 1 is equal to a into 1 minus 2, 1 minus 3 plus b into 1 minus 1, 0, 0 into plus c into this value also 0. B value 0, c value 0. Next value how much here? 3 minus 1, 2 value. 2 is equal to this value minus 2, this value minus 1. Minus 1 minus 2 plus 2. So 2a. A is equal to 1. Okay na? Correct ma? Substitution. Here 1 value is substituting, here also 3 minus 1, 2 value. This value 0 and this value 0. So 1 minus 3 minus 2, 1 minus 2 minus 1 minus 2 into 1 minus, plus 2. A is equal to 1 value. Next, similarly if you substitute the value, x is equal to 2. X is equal to 2. Then how much more? 3 into 2, 6. 6 minus 1, 5. So 5 is equal to, then this value 0. A into 0. Plus this value b value. So b into 2 minus 1, next 2 minus 3 plus c into 0. Then 5 is equal to, here 1 value, 2 minus 1, 1, 2 minus 3 minus 1, then minus b, then b is equal to minus 5. Okay na? B is equal to minus 5. Next, put x is equal to 3. Put x is equal to 3. Then see x is equal to 3 means 3 3s are 9. 9 minus 1, 8 is equal to a into 0 plus b into 0 plus c into, here what we done, 3 minus 1, 2. 2 value. 3 minus 1, 2. Next 3 minus 2, 1 value. Okay na? 3 minus 1, 2. 3 minus 2, 1. So then 2c is equal to 8, c is equal to 4 value. Now these are the constant values. A is equal to 1, b is equal to minus 5, c is equal to 4. These values are substituting in equation 1. So from equation 1, then what would have done? 3x minus 1 by, this value how much? X minus 1 into x minus 2 into x minus 3 is equal to a by 1 by x minus 1, b by minus 5 by x minus 2 plus 4 by x minus 3 value. Okay, now integrating this value. So integral 3x minus 1 by this value x minus 1 into x minus 2 into x minus 3 dx is equal to integral 1 by x minus 1 dx minus 5 into 1 by x minus 2 dx plus 4 into 1 by x minus 3 dx value. Then finally what we have done here, that is equal to log of x minus 1 minus 5 into log of x minus 2 plus 4 into log of x minus 3 plus c value. Okay na? So that is the solution for this given some lengthy this one. So if you are applying the partial fraction method, then you find out the final solution. Right, Sima? Just now I explained on the board question, integral 3x minus 1 by this one, partial fraction method this one. Suppose same question in any competitive CET or JEE main or any exams given, then how to we applying that traditional method, means lengthy process. If you are done partial sum of the partial fractions and we find out the constant value, after then if we find out that lengthy process, but except that process, especially this method, only linear factors method given means we applying this shortcut method within 3-4 steps if we get the answer. How to we find out this one means first we observing how many non-repeated linear factor, then only we applying this method. First any one factor if we taken x minus 1, x minus 1 is equal to 0 means x is equal to 1. Now the total integration, if you substitute x is equal to 1, here 3 into 1 minus 1 by, except this one, which factor we selected, except this one, x minus 1. Here we substitute the value 1 minus 2, 1 minus 3 into log of which factor we taken, that log value. Okay na? So first we take one factor, that value equating to 0, then x is equal to 1. That value is substituting in total integral except x minus 1. 3 into 1 minus 1 by 1 minus 2 into 1 minus 3 log of x minus 1 plus similarly another factor if we taken x minus 2 is equal to 2, x is equal to 2, that value totally we substituting here 3 into 2 minus 1, x 2 minus 1, 2 minus 3, except x minus 2 log of x minus 2 plus another last factor x minus 3 is equal to 0, x is equal to 3, that value we substituting in total integral except x minus 3 value. So this value, then finally if you simplifying and if you get the answer within 3 or 4 steps, that is the easy method if you find out the integral in competitive exams. Okay na? Right Sima, already explained third model, same model this fourth one, integral x by, so here non-repeated linear factors there, non-repeated linear factors. So this method I explained that shortcut method, we solve the general method, we comparing the both answers. Okay na? Right Sima, here suppose here factor x minus 1 is equal to 0 means x is equal to 1 value. Now here 1 by 1 minus 2, 1 minus 3, this factor log value plus x is equal to 2, then 2 by 2 minus 1, 2 minus 3, then if you get the value minus 2 log of x minus 2, and x is equal to 3, again we substituted 3 value, then if you get the value log of x minus 3, 3 by 2 value. Okay na? So this is the shortcut method useful for competitive exams. Fifth question ma, integral 2x by x square plus 3x plus 2 into dx, plus 2 into dx. Okay na? Here denominator quadratic expression given. First we factorize this quadratic expression, after then if we decide, otherwise factors not possible, this is the what ma, irreducible polynomial. So the first we factorize this value. What we done ma, factors here, suppose x square plus 3x plus 2 given, factorization 3x plus 2 is equal to, factors what ma, 2 into 1, so mostly x plus 1 into x plus 2 value, correct factors x plus 1 into x plus 2 value, so x into x, x square, 2x, 3x, 1 into 2, 2 value, so that's why, so that is equal to what we done this value, integral 2x by this value ma, x plus 1 into x plus 2, x plus 1 into x plus 2 dx value. Now if you take this rational fraction, 2x by x plus 1 into x plus 2, that is equal to a by x plus 1 plus b by x plus 2 value, that is equal to a into x plus 2, b into x plus 1 by this value ma, x plus 1 into x plus 2 value. Now if you comparing 2x is equal to a into x plus 2, b into x plus 1 value. Okay na? Now this is equation 1, now this is equation 2, same model. Put x is equal to, first put x is equal to minus 1. Now this value become as 0. Minus 1 plus 2 plus 1. Then minus 2 is equal to a. Okay na? Put x is equal to minus 1. Minus 1 plus 1, 0. So minus 1 plus 2 plus 1. 1 into a. This side minus 2 value. Next what we done here? Put x is equal to minus 2 written. Now this value becomes minus 2 plus 2, 0 value, and minus 2 plus 1, minus 1 value, minus 2 plus 1, minus 1. Then 2 into minus 2 is equal to minus b value, minus 2 plus 1, minus b. Then b is equal to how much more here? 4 value. B is equal to 4. Now these two values, a is equal to minus 2, b is equal to 4 in equation 1 substituted. Then what we done here? 2x by x plus 1 into x plus 2 is equal to a by, a means value how much more? Minus 2 by x plus 1, b is equal to 4 by x plus 2 value. Now we are applying the integral on both sides. So integral of this value how much? 2x by, this is the quadratic equation, x square plus 3x plus 2 dx is equal to minus 2 integral 1 by x plus 1 dx plus 4 into integral 1 by x plus 2 dx, that is equal to minus 2 into log of x plus 1 plus 4 into log of x plus 2 plus c rad. Okay na? Okay na? So right, Sima, already in that partial fractions, that exercise 7.5 we completed 5 problems. So that 5 problems given only proper fractions. So already told Nama, proper fraction means what? Degree of f of x is less than degree of g of x, then that fraction, rational fraction, is said to be proper fraction. Or improper fraction means what? The degree of f of x is greater than or equal to degree of g of x, then that rational fraction is said to be improper fraction. Whenever improper fraction given means we must and should be converted into proper fraction. After then we applying the partial fraction on the given rational fraction. Okay na? So right, Sima, sixth question, Sima, here. Integral 1 minus x square divides x into 1 minus 2x dx value. Here what given? Integral 1 minus x square divides x into 1 minus 2x dx value. Okay na? Here we comparing, numerator degree is 2, denominator degree x into 2x square. So degrees are equal. Now this is which type of this one? Improper. So this is an improper fraction. Now this improper fraction, 1 minus x square by x into 1 minus 2x. Now if we take common minus in numerator and denominator, then minus common if we take and means 2x square minus x. So whenever divisible if you apply means, if you means standard form, highest power to least power. So minus if we taken common, x square minus 1, here also minus if we taken common, this value become as positive, 2x into x, x square, positive value become as a negative, x value. Now we are applying the division. So division, how do we applying, Sima, here? So 2x square minus x divides x square minus 1. So already if you know that this process in lower section, divisible by dividend divisor, okay na? Divisor dividend. So whenever if you want to applying this one, first we take the first term in dividend, highest power term. Highest power term means how much there here? X square value there. Divides, in a divisor highest power term how much there? 2x square there. Now x square cancellation, that value is equal to 1 by 2. So that value where we write in quotient, if you write here quotient. Now multiplying with this term, 1 by 2 into this value, 2x square minus x, then x square minus x by 2 minus plus, okay na? So these two are cancellation. Next value what here? X by 2 minus 1 value. So this is the division algorithm and division method we are applying, and we find out this one. Now this one how to run? First quotient 1 by 2 plus remainder x by 2 minus 1 divides divisor 2x square minus x value. Okay na? So that is we are applying the division and we find out that given improper we convert it into proper fraction. Now we are applying the integral on both sides. Siva, integral on both sides. Integral of 1 minus x